Captain, the enemy spaceship is approaching.
They're bluffing as always. They're not going to crash into us.
I have a bad feeling about this. I think this may be a suicide mission, Captain.
What is the speed they are approaching at?
I don't know. The speedometer of the ship is down. I will check the speedometer of the nearest galactic police station. According to the measurement made by the nearest galactic police station, an outside observer, we have a speed of 0.8 c, and the enemy spaceship has a speed of 0.6 c, and we are 2.5 times 10 to the 12 meters apart right now.
Oh, it's simple then. We move with constant speed, and the distance we cover is 0.8 c times time, and the distance the enemy ship covers is 0.6 c times time. Hence, we will collide at t equals, which is nearly 100 minutes. Our crews are able to evacuate the spaceship safely within 70 minutes. So guys, we're absolutely safe.
No, Captain. According to the outside observer, we are going to collide in 100 minutes. But it is not 100 minutes for us and our crews.
Wait, what?
You need to get away from the idea that time is absolute and that your time is the same as my time no matter what.
Explain yourself at once.
We need something new to define time now. We can use a light clock. This light clock has two mirrors in the opposite directions and a photon bouncing between them. Every bounce made by this photon, we count it as one tick. Since we know the speed of light is 3 times 10 to the power of 8 meters per second, we can easily calculate it out that the time for this one tick is 2 times 10 to the power of -9 seconds, which means that every second this photon will make 500 million of ticks. Now, if you stand on that police station and look at the light clock in my hand, what do you see?
Oh, I see. Because our spacecraft is moving, I see the photon take this blue path instead of just moving up and down.
Yes, the velocity of light in empty space is a universal constant, the same for all observers. Look at the light clock on the police station. What do you see now?
This photon is still simply moving up and down.
And it traveled a shorter distance to reach the opposite mirror compared to mine in the spaceship, right? This means your light clock will tick before mine. Then also, your light clock will reach the first second before mine, and this means my time passed slower than your time. This is not caused by anything like the clock is broken and counts the time wrong. The clock is still fine, but the time itself is slower. So everything related to time is slower. What you will see is not just my clock ticks slower, my motions all get slower. You may see me use an hour or more to brush my teeth, use a week to cook a dinner. Well, I am just doing these things as normal. We give this phenomenon a marvelous name, time dilation.
Yes, what's the maths?
This is the maths, Captain. As you can see from the picture, using Pythagoras, after expanding the brackets and rearranging the expression, we can get a formula for our actual dilated time. T equals 1 over square root of 1 minus v squared over c squared times t prime, where 1 over square root of 1 minus v squared over c squared is called the Lorentz factor, or more commonly known as gamma.
Okay, is there another way to derive this?
Yes, Captain. Consider a ticking clock in our ship. 2 ticks occur at TA prime and TB prime. The events can be represented by these vectors. Using the Lorentz transformation, we can show that the corresponding events in the station can be represented with the following vectors: gamma VTA prime 00 gamma CTA prime and gamma VTB prime 00 gamma CTB prime. This means CTA equals gamma CTA prime and CTB equals gamma CTB prime. The time between the ticks in our ship, delta T prime, is equal to TB prime minus TA prime. So the time difference between the ticks according to the station must equal to gamma delta T prime.
Okay, I understand. Our speed is 0.8 c. According to an outside observer, we have 100 minutes till the crash, and evacuations take 70 minutes. Given the formula that you guys have shown me, I can work out the time that we have till the crash. We have 60 minutes. Well, it was nice knowing everyone.